Okay, in tonight's Unity tutorial, I want to show everything about voxels. Okay, and a voxel is like a cube. So right here we have some cubes, or what I'm calling voxels. All right. Um, Now a voxel, if you look right here, this one kind of looks like a Minecraft brick. And that's basically what I'm going to do with this. With this voxel idea is try to make, a Minecraft-like terrain game sometime in the near future. But here we got like 3 voxels to demonstrate the 3 levels of voxeling here that we could do when we make a mesh through a C# script. So the first one here, this blue one, it only has 8 vertices. There's 8 points, and the 8 points are connected by triangles. And then the shading is done. And the shading, basically, since there's 1 point here shared between all these sides, the light kind of blends between them. Then on here on the second voxel that we're going to do, this one is going to be more like what I'm going to have in the Minecraft game, where each side, each corner, oh, there's a little boo-boo there, but each corner has its own copy of that point so that the lighting could be calculated just for that side. And this is kind of like a flat voxel. This one was a smooth one. This is like a flat voxel where each side has its own lighting calculated and there's no blending between the sides. Now with this kind of voxel, I could map a texture onto each side, like the way I took this monkey, made it into a material, and then map the picture of the monkey on each side of the voxel. This one here is something where I really took advantage of mapping what I wanted on each side of the voxel. And what happened is I had a texture here where there's basically 3 different textures. There's the grass, the dirt, and the grass and the dirt like this. And then I determined where to pull from in the texture to put on the voxel side. So that's my 3 voxels. So first we're going to go over the simplest one here, which is the blue one. So let me just hide these guys. And let's zoom in and focus on the smooth voxel. This is the easiest one to do first because it just has 8 points. All right, so as you see, there is nothing there when I started off. I just have this empty game object that I kind of created, and then I just added the corners here so that they could display themselves. So let's take these guys out of the picture, and now we only have these 4 points here, these 8 points. So on the bottom I have A, B, C, D, and at the top I have E, F, G, H, and I'm going to use those same letters for the corners in all 3 of my voxels here that I'm going to demonstrate. So for the smooth voxel, this is basically the center of the smooth voxel, its position in the scene, and then the corners are basically offsets from the center, so that the center of the voxel is the center of my game object. So let's see, this voxel smooth, I made it with a C# script. So let's take a look at the script. All right. Here this is the script for the voxel smooth, my easiest made voxel. And when I make a voxel, I'm basically going to be defining the mesh over here from the mesh filter. So right now this voxel smooth, it has the transform. Then I added a component for a mesh filter. I added a component for a mesh renderer and a mesh collider so that if something touches it, I could detect collisions. And then I added a script. So if you were going to do this yourself, this one is one that I already made. Let's see, I could just here add another empty game object. Okay, except this one here, it's coming out in this position. Let me just move it over a little bit over here. Okay, I added the empty game object. And then I take the Voxel smooth script and I drag and drop it onto my game object. And automatically the script added in the mesh filter, the mesh renderer, and the mesh collider. And here's a script. And then when I run it, the script kind of creates the voxel shape, the cube shape in 3D. The only thing is this one here, everything is pink, and this one, everything's blue. And the reason for that is because I have one more step here. I have to add in the material here, element 0. So I could take my color material, blue, and drag it on there, and then you see now I have everything. So it renders just like this one. The points aren't showing on this voxel because I don't have this child object, the corners. See, I just added those in so when I'm talking about it, we could understand it better. All right, back to the script. Delete this extra guy. So again, I have this voxel, and these points are just showing with this corners object. Okay, and these letters here are just made by picking the icon, and then it just shows the letter. All right, so these require component statements are what automatically add in the mesh filter, mesh renderer, and mesh collider if they're not there. Then here's the beginning of my script. And for public variables, I have 3 different arrays. I have an array of vector3 for the vertices. I have an array of vector2 for UV coordinates. UV coordinates tell the mesh where to get its texture from on the picture. See, like here's 0, 0, here's 1, 1. So UV coordinates are vector2. You give it an x and a y from a flat picture. And now these two things, they define the points in space and where they're going to get their picture from. This third array is the triangles that are going to make up my mesh. Okay, and then here is a pointer to the mesh from my game object. All right, so this mesh is going to point to this mesh filter mesh right here. Okay, because once I define the vertices, the UVs, and the triangles, then I'm going to set those 3 arrays to the mesh, and then I'll tell the mesh to draw itself. So let's see, when the script starts up, it runs the start function, and the first thing I do is I get the mesh object. I want to define this so it's not null. So we look here in the get mesh, and this is just something I figured that I had to do because I was having memory errors. So when the Unity, this is the Unity in editor mode, and if I press play here, then the Unity application is in editor mode. And when I'm in that mode, I have to use the mesh filters shared mesh to set to a new mesh. Otherwise, if I had done the build for the game and everything, a build and run, and it's not using the editor window, then I would set the mesh filters mesh. All right, so if I'm using the Unity editor, I set the I make a new mesh on the shared mesh of the mesh filter. Otherwise, I'll be making it on the mesh. So this sets the mesh filter to have a new mesh object. And then over here, I have the mesh collider. I got a pointer to the mesh collider right here. And I just set the mesh collider's mesh to equal the mesh from the mesh filter. All right, so we know what we're colliding into. So this is all just setting up my little scripts pointer to a mesh for my game object. All right. Then after that, I'm going to do the init voxel data for my smooth voxel. And here I just have a little diagram and comments of my points like A, B, C, D on the bottom, E, F, G, H on the top of my cube here. And then for each point from the center, A is an offset of minus X minus Y minus Z. And this just helps me figure out like how to do all the points. It keeps me as a reference here, okay? So first thing, how many vertices do we have in this voxel? We have 8 of them. All right. So the indexes to the vertices are going to be set. I'm just going to use these letters, so we don't have to think of it in numbers, but we can think in letters. So A is vertex 0 all the way down to H, which is vertex 7. So 0 to 7 are 8 vertices. And then when I set the point for the vertice at A, I just kind of reference here for my A that it's a minus, minus, minus. So the new vector is the minus, 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 which is low, 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 which is minus 0.5. So go half a unit away on that side, and for the high, it's half a unit up. All right, so this is like an easy way for me to define the vertices where I kind of could I don't get too mixed up with the numbers because I'm either going down or I'm going up. I'm either using the low value or the high value, and I make all the vertices here, and there's 8 of them. Now, there's a rule here that for the vertices, if there's 8 vertices, then the UV count has to match the vertex count, okay? That's a rule for the mesh in Unity, that the vertices and the UVs, they have the same number. Because basically what this is saying is that for vertex A, where do I look for, what do I put, what part of the texture do I map to vertex A, what part of the texture do I map to vertex B, etc. So for every vertex, I have to set a UV to tell it where it's going to map. So here, I just have 8 vertices, and each corner is being shared by 3 sides. So to say that E is just going to map to this corner of the monkey or corner of the blue, it's all blue. So it doesn't really matter. So all the UVs, I just set them to 0. So I got the vertices and the UVs. And then the third thing I have to do are the triangles. So how many triangles do we have here? We have 36 indexes to make triangles, since each triangle has 3 points. And let's just look at it. I'm going to render it again. The reason I come up with 36 is because each triangle has 3 points. 1, 2, 3. 1, 2, 3. That's 2 triangles per side times 6 sides. All right. Which, do I have too many triangles? I don't. All right. So the triangles, let me try to show this side by side. Let me press play on this again. Let's see, we have a triangle here, AEF, and here's my first triangle. The points are AEF, and then my second triangle is BAF, BAF. Now, a thing to note here is that you have to connect the points of the triangle in a clockwise order. All right, so connect the points of triangle in clockwise order. All right, so if I'm looking at it from this side and I connect them in a clockwise order, this is the side of the triangle that will get rendered. If I were to look at AEF from the other side, and let me just get inside this triangle, boop, there's nothing to render, because basically Unity is not going to waste time drawing the inside of a game object. You're not going to see the inside. If I try to go inside, you see how you don't see the inside of the triangle. So that's called backface culling, where it only draws a side that's visible. So the way you control what side's visible is you control the order that you connect the vertices in. All right, so here I connected AEF, and this is the side that draws. But if I switch it around, let me press stop, and instead of AEF, I said FAE, FEA, I mean, and I switch the order to counterclockwise. Let's see what happens. And then I press play. This triangle, from this point of view, is not visible. It's visible from this other point of view. I'll just go in. You see, it's visible from the inside. So if you have little holes like this, it could be because you connected your triangle in the wrong way to the way you're viewing your side. All right, so let's put that back to AEF. So this here, these are the points for the backside. And, well, did I save it? I didn't save it when I fixed it. AEF, and there's a little star there. Save it. Okay. So I have 6 sides, and I just named each side. So this is the EFAB side, which is the back side, because this is the z-axis forward, so that means this is z-axis back. So this is the back side, this is the right, the left, the front, this is the top, and then down here is the bottom. All right. So that's what I did. I just connected all the triangles, and as I was going around, say for the next side, the right side, I just used these little corners that I have displaying here to help me, set everything properly. Like this should be BFH and DBH. And did I do that? BFH and DBH. And then I went to the front and I did the same thing. And then it's kind of tricky when I go to the top. I look at it from the top. It would be EGH, and where we got that EGH and FEH. And then from the bottom, I just actually turn my view to the bottom, and I have CAB and DCB. Okay, so this makes my smooth voxel. Now, what would happen if I had the smooth voxel and I tried to actually put like something like the monkey on it? Well, it doesn't really work out right. I can only kind of calculate like 2 sides to look right, and the other ones, they come out all funky. So if I'm using the smooth voxel thing, I'll just always have it like as a color instead of trying to map textures onto it. And let me see, so that was all this. And then after I set my 3 arrays, the vertices, the UV, and the triangles, I actually set the mesh data. So these arrays, they're just here in my script, but I have to actually get them on the mesh. So here in set mesh data, I take the mesh and I clear all the data off the mesh. Then I set the vertices of the mesh to equal my vertices, and the vertices are an array of vector 3. The UV are an array of vector 2, and the triangles are an array of integers, the integers that point to which vertex to use. These are kind of nifty functions here. The recalculate bounds, recalculate normals, and recalculate tangents. So the recalculate bounds, this is so that Unity could know the size of my mesh. Okay, and then the recalculate normals are for lighting. So Unity could know how much light to put on a side. And then the tangents, this one was a little confusing for me, but it's for shaders, but I don't have any shaders. But what the heck, I'm just going to recalculate it right there anyway, okay? So that's what these 3 recalculates are for, because after you set all these things, Unity kind of has to determine what's the light on that triangle, what kind of light is. So that's what the normals are, that's important. And I guess the bounds will be important for collision. All right, and then with that, that's how the triangles get rendered, and we get our voxel. So this was the easiest voxel to make the voxel smooth, and it's easy because we had the least amount of points. Okay, now let's see what happens when we do the next difficult voxel, which is the voxel flat. So let's turn off the voxel smooth, and let me turn on the voxel flat. All right, here's my voxel flat. And now I just have it here that I broke it down to sides. And I think I have a little mistake here in my points. Like right here it says AC, this is point E up here. So what side is this? This is the left side. So here's the left side. So something's messed up over here. So let's see, G, oh, that's supposed to be an A. Let me just change that letter. So it's not going to confuse me, and this should be a C. And this should be a E. And this should be labeled a G. Oops. Label added G. Okay, there. Fix that little mistake. Save that. These are just labels, remember. Okay. So here's my voxel flat. And let's just have this guy render out so we can see what we're looking at here. Boom. And for the voxel flat, it's using this material right here instead of the blue. It's using this material. It could easily be the blue if I want. I could just drag and drop the blue on there and it could be blue. But you could see how it's different since this one, each side is rendered like a flat voxel. The light is just calculated for that side and the whole side gets the same lighting compared to the smooth voxel where the lighting is like blended between the sides. So that's one difference about the way the normals are calculated. This one has a set of vertices for each side, so that's why the lighting is flat on each side when this one is sharing it and the lighting is blended. Turn that one off again. And let me put back on the monkey. So the reason I'm putting the monkey on here, did I put it on there? Oh, I put on the wrong guy. Put color back on my smooth voxel, select my flat voxel, and put the monkey back on my flat voxel. Now the reason I'm drawing a picture of a monkey's face here is because now the UV mapping is really going to come into play. And if I map the things with the wrong corners of the picture, so say here on this side, my back side, let me just hide all other corners. And let me just show the back side. See, so I have EFAB. I have to make sure that point A on my backside is mapped to the bottom corner of a picture for its UV. Point B maps to this corner. And the same thing for the other points. E over here and F over here. If I look in the code, let's look at the code for my voxel flat. It's a little bit different than the one for my voxel smooth. Here is the voxel flat. It still makes sure that the game object has these components, the mesh filter, the renderer, and the collider. And it still has 3 arrays, one for the vertices, the UV, and the triangles that I'm going to define. And it still has a mesh. And basically, the function names that I'm using, they're still the same. The only difference is the vertices and the UVs are higher. These are 24 vertices and 24 UVs because like I said here, I have a set of vertices for every side. So instead of just 8, that gives me 24 points to make this voxel smooth, flat shaded. All right. Boom, boom, boom. All right, let's look into the difference in the functions here. Hello, monkey. What's the difference in the functions? Start basically calls the functions in the same order. First, I get my mesh object. I still need that. So that's going to be the same as it was in my voxel smooth script. Here I get the mesh filter and mesh collider components, and if it's the editor, I use shared mesh. Otherwise, I use mesh, and then I set the collider shared mesh, so that function's the same. The init voxel data, that's where we're going to have our differences. Now this one's going to be a little bit longer and a little bit more complicated. So I broke it down into sides when I was defining the points, the data. So here is the first side. The back side is made from the points E, F, A, and B. These blues, the blue side over here. So here's E, F, A, and B. So for my vertice array, that's 0, 1, 2, and 3, the first 4 vertices. And let's see, E is a minus, a plus, and a minus, because here from the center, minus X plus Y to go up, and then minus Z to go back. All right, so anyway, I just got to follow my comment here. EFAB, and then I have, for these 4 vertices, I have 4 UVs, and let's see if these are going to work here. I have, for point E, this is up here at the top, so that should match up to the monkey's top here. So that's 0, 1, X0, and Y1, 1, 1, 0, 0, and 1, 0. And then the triangles, just like in my other one, for the smooth voxel, are just made up of all the different indices for vertices. So I have AEF, and where are you, B? BAF. Okay, so once again, that's what I did. This is EFAB, my backside. Then I turned around to look at my right side and just see what I have. Voxel flat. On the right side, I had these green ones here that I look at, and I just rotated around to all the sides to get the voxels face defined and the UVs defined. So the right, the forward side over here, the left, it's over here, and the top here, the upside, and the downside. And I define all those points. Okay. And after that, then we called set mesh data, and this function's the same thing as it was in the last one. So now let's see what happens. I'm gonna just add a little function here. I'm gonna add a private void update, and on the update, I'm just gonna keep calling set mesh data so that I don't have to rerun the script to when I change some of the values around, and you can see what happened. All right, so let me just start this again with the new script that I just changed with the update function. And there you go. So luckily for my voxel flat, my script right here, I expose all the vertices. See, so I could move them, right? Minus 0.5. All right, so those are the vertices. These are the UVs. So now the UV, let's see, the first 4 UVs, 0 to 3, are for this backside right here. And if I start playing around with them, you can see it's going to take from, instead of taking, if they're wrong, things kind of move around. All right, so this is how the UVs are taking into effect. So the X value, like where in the X do I have this top corner E mapped to? And if it's just straight 0, it's there. So 0, 1, 1, 1. How about if this was 1, 0? What happens? It's just when the numbers are off, it's saying here for the corner that's F to take it from X is 1 and 0. It's saying take it from the bottom corner. So you could do some weird things there with the texture. But if it doesn't come out like boop right where you want it on the mark, that's probably because the numbers are wrong. And you just have to look at that side and put the UVs in the right way. Or, just take what I have here. Now for the triangles, these are all the indices, the indexes to these points. All right, so that's the flat voxel. Now what else we have? Let's go to the fact that since we are rendering a monkey on each face, what if we render something different on each side of the voxel and we get something like this? Boop, like the Minecraft cube, since I'm controlling UVs. So how do I get to render different pictures on different sides? One of the tricks is to actually have the thing that I'm mapping. Here is my texture map here, and it has actually 3 different pictures in it. They're just in different locations, but here's the texture itself. Let me just try it up. Should I open it with? What program can I have? Oh, just open it with the easy, here, this guy. And here we go. So when I have the UVs with the monkey, I just said 0 and 1, right? It's the whole picture. You're either at position 0 or all the way up to the top is position 1. In this picture, I have 3 different little tiles, 3 different little pictures. So when I have the UVs, I could say that for the top to the bottom, it's still 0 and 1, but when I right, this is 0, this is 0.3, this is 0.6, and this is 1. All right, so that's the difference we're going to see in this one. When I set the UVs, they're going to be a little bit more flexible. Oh, okay. So let's go into, this is the Voxel dirt. And let's look at its script. Where are you, script? Right here, double click. All right, what's different? We have more data. So to help me, I made like a little helper section here. We still have the require components so that when the script goes on the empty game object, we make sure it has a filter, a renderer, and a collider. Then I have some helper data. To talk about the corners, I have an enumeration, which just enums out all the corner letters. I have an enum texture, excuse me, which is going to enumerate the names of these 3 textures that I have in the picture, right? So the first one I'm going to call grass. The second one, I'm just going to call the whole thing's dirt. And then the third one is grass on the top with dirt on the side. Okay, grass on the top with dirt on the bottom. All right, so I have a enum for that. And now for the sides. All right, since we're dealing with more data, I'm just trying to make things easier to talk about. So I made an enum to describe each of the sides. So the back side is EFAB, and the right side is FHBD. So this enums the sides, back, right, forward, left, up, and down with their vertices. And I still have my 3 arrays for the vertices, the UV, and the triangles, 24, 24, and 36. And then I have this little variable here, which will show in the inspector, which will give whoever's using the script an opportunity to tell the script how many tiles are in the X direction and how many are in the Y direction. So in my texture that I'm using here, I have 3 tiles in the X, but there's only 1, row of Y. So if I look over here, you see I got 3 in the X and 1 in the Y. And that helps me calculate which texture show on a side. I still have to have my pointer to a mesh. And here I'm just optimizing a little bit, since if I in update, I'm going to keep calling set mesh data, set mesh data. If I just am going to use any variables over and over again, I'll just make them appear as member variables. So I have that, and then for my low and the high, you'll see what I'm going to use these for when I'm positioning things. All right, so the start function, it still says get the mesh object, which, we're depending if we're in the Unity editor or not to get the shared mesh or the mesh from the mesh filter. Then I have the init voxel data, and this one looks a little bit neater. This one, I kind of have functions to get every side vertices, every side UV, and every side triangle. Okay, so this is like making the back, the right, left, blah, 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 right? So now if I wanted to just make 2 sides like the back and the right, I would just basically call these 2 guys. Let me save that and rerun it. And it just makes those 2 guys. And, it's just because when I make the Minecraft game, I'm gonna start wanting to control which sides are actually rendered. So anyway, this is initting all the voxel data. So what happens when I say set vertices for a side? and I tell it that the side is the backside, it's going to actually go over here and call set vertices side. Let's see what that does. Inside it, here, set vertices side. So we're going to have to know, since the vertices go from 0 to 24, I want to know which index in the vertices do I start from. So based on the side, let's see what we had over here in the side. Enum side, this is 0, 1, 2, 3, 4, 5, right? That's the enums have a numerical value. So the first one by default starts at 0. So down here, I'm saying for side 0, and how many vertices are for each side? 4 of them. So this is where I'm going to start. I is going to start for the vertices that I'm going to start defining. All right. So if I'm on the back side, that's 0 times 4 is 0, so I equals 0. So vertice at 0 is going to equal corner E. Yeah, so this is another function I'm calling, breaking it down even more. So let's go to the definition of corner. Corner is right here. And what corner does is it returns back a vector 3 for the corner I'm requesting. So if I'm requesting corner A, it's just going to return a vector 3 low, low, low. B is a high, low, low, and et cetera, et cetera. And here I just put a default to make sure if anything goes wrong, if I see corner error appear here, I know somehow something went wrong. So the corner thing now, I don't have to think about the low, 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 high, low, low. I just kind of give it a letter, and that method gives me back the vertex for that letter. Okay, so it's kind of like easier to read. So the back side is made up of EFAB, the right side is made up of FHBD, and I kind of make all the vertices just like that. Okay, and this is, you can read it there. What else happened? After I set the vertices, then I set the UV. Okay, so for the UV, I just have to know what side, and then what texture do I want to set on that side. So grass dirt, that is the second enum right there, equals 2. And did I lose my picture? No, I didn't. There it is. So this is 0, this is 1, and this is 2, the grass texture. So let's see what happens when we go to set side UV, go to definition right here. All right, so that this is flexible to work with any texture that somebody puts in here. I'm using that textures in direction inspector thing. So in the X direction, I have 3, because here in my inspector window, textures and direction, you can see that X is 3 and Y is 1. So 1 divided by 3, that's going to give me like the 0.33. So the percentage I move along on the X for each texture is 0.33. So 0 to 0.33 is the first one, 0.33 to 0.66 is the second, and 0.66 to 1 is the third. All right. And then, you know what, it's going to be easier to show you this if I run it in debug mode. So let me just put a breakpoint here and show you what happens with the numbers. I'm going to press attach to Unity, and then I'm going to start up Unity again. Come on, baby. There we go. I start up Unity, and we're coming in here for the backside and the grass dirt texture. Textures X, I have 3 of them. So the percent, I said it's going to be 333. And yeah, it's 0.333333333. And then for the Y, there's only one line of images in my texture. So that should be equaling to 1. And now 0.0 for the texture that they want, grass, that's going to be like, it's the texture equals grass dirt, so that should be a 2. To grass dirt, the end of grass dirt would be like whatever the next texture would be, is grass dirt 2 to 3. All right, so my low value for my UV, like the bottom corner, of my UV, whatever the bottom corner is going to be, is going to equal 0.7 and 2. And then my high value is 0.1 and 3. All right. How many sides do I have? This is the back side, 4 UVs per side. So when I'm going to start populating the UV array, I'm going to start here at position 0. Okay, now the side I'm doing is the back. So one easy thing is the back, the right, the forward, and the left sides, they all have the same UV mappings. That's what I decided to do for them. They have the same. So the first thing is these are the mappings: low, high, 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 low, low, high, and low. Right? So what does that look like? We got the 0.7313, 7212. Okay, we got that. And then it comes around again. This is the right side. It's still the same texture. So the only thing different, right's going to come in here too. Let's come again. And let's wait until we get like the up, left, up. All right, so now this is the top texture, which I'm going to want the grass, right? Yep, it's the grass. So the percents are still the same because the texture is broken up into 3 and the points. And then here's my low, my high. It's a little different now because I'm trying to get this one. And then the mapping's different on the top than it is on the sides. So you can see the pattern here. Instead of the minus, plus, 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 minus, minus, plus, minus, blah, 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 it's different. It's this pattern for the top. And also down is different. Down is unique. Okay, let it run. And then therefore we have our cube that we saw before. Okay. So let me see, what else do I have to explain here? I mean, you're going to see, you can get the assets for this, the scripts and everything from omarvision.com. And you can get them from here if you want to download the assets and try this project out. So you have to type all this out. You can just go here to omarvision.com, go to tutorials, and then at the top type search for, Voxel, the word Voxel, and it'll show all the Voxel videos, and this one should come up. And then there's a link at each video for the actual assets. You can click it and download the assets. Set UV. And the last thing here was after it sets the UV, it sets the triangle sides, right? So same thing, except for triangles on a side, there's six indexes per side, because it takes 3 points for a triangle, 2 triangles, that's 6. So here, if it's the back, then the from the vertices array, E is 0, 1, 2, 3. EFAB is 0, 1, 2, 3 for the back side. The right side, the indexes into the vertex array are 4, 5, 6, 7, and so on. Okay. And what else can I show you? It's been a long video. It's been a long day. All right. Any questions, just ask them in the bottom there in the comments. And hopefully this was explanatory. All right, let me just run this there. There's my last picture. Boom, the 4 of them together. No, the 3 of them together. Ta-da! And one other cool little thing here is if you ever wanted to see what the data is for any mesh that you kind of like would throw into Unity, I have this script here called, I think I have it as an extension, a C# extension. Yeah. So what I did is I made a static class, my extensions, and I have a static function export to desktop. So anywhere you have the mesh object in Unity, you could call export to desktop, give it a name for the file you want to save, and it'll save out a file like this. So for Voxel dirt, it actually exported all the data, all the vertices, the UVs, and the triangles, and things that we didn't set, but we use recalculate normals, and we use recalculate tangents, and we also did recalculate bounds right here. And it tells us how many vertices. This is all the data from the mesh object of Unity. It just spills it out into a file. So if you have to debug your mesh that you're making, it kind of help. Or if you want to kind of like take a mesh that exists and see the data, you could actually do this too and spit it out to a file. So that is here in my assets here. Also, it's this one, my extension. Whew, okay, there you go. Bye-bye.